Hello everyone, my name is Malaika Sir and my department is BS Chemistry. Today I will be presenting on a very interesting topic, curium. It is a synthetic element with powerful applications, especially in the nuclear sciences and space exploration. But it is also carries serious health and environmental concerns. Let's explore it in depth. What is curium? Curium with the symbol Cm is a man-made radioactive element. It belongs to actinide series on the periodic table and has the atomic number 96. It was first discovered in 1944 and named after the famous scientist Marie Curie, who was knowledge in radioactive research. This element doesn't exist in nature. It has to be created in the lab or the reactor. Physical and chemical properties. Physically, curium is a silvery white shiny metal. It looks somewhat like other actinides. It has a density of 13.5 grams per cubic centimeter, which is quite closer to uranium. Its melting point is very high, over 1300 degrees Celsius, which make it stable at high temperatures. Chemically, it's quite reactive. It reacts with oxygen, water, and acids. It easily forms compounds, and one of the most important one is curium oxide. Its radioactivity is one of the most defining features that makes it both useful and dangerous. Discovery story. The discovery of uranium was a big milestone in the science. It was first element discovered after protium. Scientists produced it by bombarding protium-239 with alpha particles. That's how curium was born, in a lab not found in nature. This was more than just creating a new element. It pushed the boundaries of nuclear chemistry and allowed us to synthesize even heavier elements. Naming it after the Curious was a tribute to their work in radioactivity. Production of curium. Since curium does not occur naturally, it has to be synthesized in nuclear reactor. The main method involved bombarding protium with alpha particles, which add two protons and create new curium isotopes. Another important method is neutron bombardment, which is used to produce a scientific or specific isotopes like Cm244. These processes require very high energy and are done in specialized facilities due to radioactive nature of the material involved. Curium in mineral analysis. One of the most useful application of curium is in mineral analysis. The isotope Cm244 is particularly helpful because it emits the alpha particles. These can be measured using a technique called alpha spectroscopy. This allows the scientists to identify the specific isotopes and elements in ore samples and even helps in dating mineral formations, a field called geochronology. So, curium plays a valuable role in earth sciences and mining exploration. Reaction with oxygen oxide formation. Curium, like many reactive metals, react with oxygen when it's heated. In this reaction, four atoms of curium combines with three molecules of oxygen gas to form a solid compound called curium 3 oxide, which is written as Cm2O3. This oxide is a reddish brown solid and has a very high melting point, making it quite stable. It's called a squeeze oxide, meaning the ratio of curium to oxygen is 2:3. This type of oxygen or oxide is typically for heavy elements like actinides. So overall, curium behaves like other metals by forming a stable oxides when heated in air or oxygen-rich elements or environments. Reaction with water hydroxide formation. When curium comes in contact with water, especially when it's finely powdered and water is warm, it reacts slowly to form a compound called curium Hydroxide, which is CmOx3, along with that, release the hydrogen gas as a byproduct. You can actually see the bubbles forming in lab conditions if the reaction is fast enough. The reaction shows that curium behaves similarly to alkaline earth metals or lanthanides, forming insoluble hydroxide form compounds. The hydroxide appears as a greenish solid and in the does not dissolve enough in water easily. So in short, curium reacts with water to form a solid and gives off the hydrogen gas, especially if the conditions are warm. Reaction with acids, salt formation. Like most metals, curium reacts easily with strong mineral acids, such as hydrochloric acid. In this reaction, curium metal dissolves and forms curium chloride, a soluble salt that can dissolve in water. At the same time hydrogen gas is released, you will notice that this is similar to reaction with water but much faster. This kind of reactions especially is typical for metals that find or may form the plus 3 oxidation state, and it shows curium chemical similarity to other actinides. Curium 3 chloride is an important compound used in separating curium in natural and nuclear reprocessing. Curium in nuclear technology. Curium plays an important or major role in nuclear technology, especially in the radioisotopes thermoelectric generators or RTGS. These devices convert radioactive heat into electricity. RTGs are extremely important in space missions. For example, NASA used curium powdered RTGS in Mars rover and deep space probes. Why? Because curium isotopes like Cm242 and Cm244 release a steady and low thermal heat which can be converted into power even in a deep space where solar panels does not work. Health and safety concerns. Now let's talk about the serious side and the other side, the health risks. Curium is highly radioactive. If it is inhaled or ingested, it can cause a severe internal organ damage, especially to the bone and the liver. Long term exposure can lead to cancer and radiation burns. That's why it must be handled with extreme care using gloves, lead shields, and fume hoods in controlled environments. Strict safety regulations are followed whenever the curium is used. Curium role in medicines. Interestingly, curium also has a medical uses. Isotopes like Cm244 are used for diagnosing imaging, while Cm242 is being researched for radiotherapy in cancer treatment. These isotopes emit alpha particles which can destroy the cancer cells, which make them Cm244 useful in its 18 years half-life, which allows it to be effective for longer term treatment or tracking inside the body through imaging. Environmental considerations. Let's not forget the environmental impact. Curium waste is extremely radioactive and can stay dangerous for thousands of years. If it leaks into the soil or water, it can bioaccommodate in plants and animals. So, curium waste must be stored in deep geological repost far below the earth's surface. This requires a careful monitoring and contaminate to prevent the contamination. Environmental safety is a top priority whenever curium is produced or used. Curium a versatile element. So it's a wrap up. Curium is a powerful man-made element. It is used in nuclear acid, energy, space exploration, mineral analysis, and medicines. But it is also very dangerous, requiring strict safety protocols. Its potential is huge, and with continued research, we can use it more safely and effectively in the future. Curium is a part of broader discussion about the nuclear sustainability. While useful in space and medicines, the question of long-term waste disposal remain unsolved globally. Scientists are actively researching safer alternatives and researching technologies for radioactive elements. Its potential is huge and will continue research we can use it more safely and effectively in the future. Thank you for listening.